Hello everyone, today I will talk about using a greedy approach to solve the longest increasing subsequence. You are given an integer array like this: 8, 2, 6, 1, 5, and 9. You have to find the longest strictly increasing subsequence. Before solving this problem, first let me ask you a few questions. For the integers 8 and 2, which one can be easy to expand into the increasing sequence? The integer 2 has more chance than the integer 8. Why? Because 2 is less than 8. For this given array, you can expand the length 1 subsequence to the length 2 subsequence with 6 or with 5 or with 9. However, for 8, only 9 can expand 8 to the length 2 sequence. Then for the sequence 2, 6, and 1, 5. Which one can be easy to expand to the longer increasing sequence? The sequence of 1, 5 will be easy to expand since the last atom of 5 is less than 6. For example, if we have 6, add a 6 here in the given array, we can expand 1, 5 sequence with 6 and 9. It becomes the length 4 sequence. However, for the 2, 6 sequence, you only can attach 9 here. So we found for the same length of the sequence, the optimal sequence is that with the smallest integer of the last atom. Our problem now becomes finding the last atoms of the optimum subsequence. To find the longest increasing subsequence, we need 3 Python lists, one to store the end element of the subsequence, and the second one to store the index of the end element, and the third one to store the index that points to the predecessor of the end element. The predecessor index is initialized with none for every item in the input array, since every item initially forms the length 1 subsequence and its predecessor is none. Because we want to find the increasing subsequence, we set the end element of the length 0 subsequence as a negative if, and its index is none. Now we are ready for searching the longest increasing subsequence. For this example, the first element 8 is larger than the end term of the length 0 subsequence, so we expand the subsequence list as well as the index list. Next element 2 is less than 8, but larger than the negative inf, so we replace 8 with 2. At the same time, we replace the n-term index with the index of 2. but we keep the previous index as none since the length still is 1. Next item 6 is larger than 2, so we expand the list and the n-term index. The previous index we change to 1 because the sequence is 2, 6. Now the next element 1, which is less than 6. So we replace 2 with 1 since it's the best solution for the length 1 sequence. We also replace the index list. But we keep the previous index as none since this is a length 1 sequence. We keep doing the process until the end of the input array. Now we get the longest increasing subsequence. What's a sequence? So we can get it from backward. So you see the index list is 5, correspondence elements 9, and then previous index is 4, corresponding to element 5, and then the previous index point to the element 1. So we got the longest increasing sequence 1, 5, and 9. In addition, we also found the list of the subsequence is strictly increasing, so we can use binary search to find the position to insert a value. Alright, let's see the code. First, we initialize 3 Python lists. Then we use a binary search to find the location to insert the value. If the location is equal to the length of the subsequent list, we expand the subsequent. Otherwise, replace the value at that location with the current value. Last, we trace back to get the longest increasing subsequent. Okay, that's all for today. See you next episode.